This is a more handsome version of Joey. Seth Juarez here on the Microsoft Ignite live stage with Executive Vice President of Azure, Jason Zander, who many of you saw earlier on the stream, delivering a fantastic tech keynote, and now we have the chance to go even deeper. By the way, for those of you that have questions, make sure to go to aka.ms/MS Ignite Live. I think I got it right. If not, they'll tell me in my ear and they will scream. I want to make sure that we get the questions, because it's not about what I have to say, but the questions that you have. How you doing, my friend?
I'm doing very well, thank you.
That was an awesome keynote. Those things take a long time to prepare for.
There is a lot of prep on those, especially when you're going to drop equipment on the floor.
I saw that. Those of you watching, when they dropped the computer, I was like, like when you practice that, was there some mild?
Oh, yes. I mean, when we developed the thing and landed the first one, yeah, definitely. I mean, at this point, we spent a whole bunch of industrial design on it and built the thing out. So it's in really good shape, you know, and just keep kicking it around on the stage. It worked really well.
That to me was probably one of the best parts. But the other thing that I saw that I heard a lot about in Satya's keynote, and you talked a little bit about it, was something called Azure Arc. Why don't you explain that to a little bit more? Because I feel like I kind of got it, but I didn't get it. Why don't you help us out?
Well, I mean, it starts off with the fact that everybody's got these, extensive environments. I've got my multi-cloud that I might be trying to target. I've got my own on-premises data centers. I've got edge that I got to be able to go target as well. And so if you think about that, you got all your engineering teams, your IT team, we're all trying to figure out, and there's these bespoke sort of versions that are out there. So what we really wanted to do is to come back and say, how can I go back and define a consistent set of management and policy, security rules, et cetera, and be able to have that apply to all of that topology. And so the way to think about this is Azure Arc allows me to go off and do those sort of management work, security, et cetera, and across all those form factors I'm going to deploy to.
So if I'm understanding this right, like it's an approach where we recognize the reality of technology today, and we recognize the reality of needing to have consistent policy, and Azure Arc helps you do that in a hybrid environment.
No, that's correct.
Okay.
I mean, like the worst possibility is, hey, I've got awesome new technology. The bad news is you got to start from scratch. Like we don't want to do that, right?
Yeah.
And so in some ways, being able to embrace and meet customers where they are. I have these topologies. I have stuff already deployed. I've already got potentially a version of Kubernetes. I got virtual machines out there. I don't want to actually have to retool all of it. I want to be able to work with it, but I need to get to some level of consistency. So that's really where we come in and provide that sort of tooling. And I think the great example that Gabe showed on stage was actually looking at, are your ports closed? Because that's the number one thing. You deploy web workloads and stuff. It's like, did you close the ports or not? Like, you kind of need to know that. And it doesn't matter what I'm actually running the tech on. I need to make sure that that's there.
Now, describe the hybrid. Like, if I have my own rack in my building, let's say I'm a bank, and I'm trying to see if how does Azure Arc actually help with that there? Is there something I install? Or how does it actually know to do the right thing?
It's all based and built off the top of the kind of Kubernetes ecosystem that we have, and it uses all the standard protocols that are there, which makes it super simple. That's why, for example, I can go into your existing environment and make that work, because we're embracing those standards. Now it's able to pull down just enough software to be able to do that level of automation, and then of course the portal and the rest of the kind of work that I do, that's all standard and applies to everything. And if you're already on Azure, you're already doing a bunch of it.
I see. And that to me, like, as I didn't realize, I thought we built this whole new thing that you have to install on your machine, and it's not a whole new thing, it's the standards-based approach. And tell us why we went that way. Why did we go that way?
And again, it comes back to meeting you where you are. So if I had to come back into your existing environment and completely pave it down from scratch and say, okay, but now it works, it's like, well, that's also a whole bunch of change. Now, so if you've already made the investments on some of those, we want to make sure that you can actually take advantage of that. And so from that perspective, using the standards-based approach in order to get the right kind of software there is an obvious part of that. And then being able to connect the two and have one ability to run all of it, that's the core.
And that's amazing. Can you describe some of the scenarios? Because obviously we test this stuff out. Can you describe some scenarios where you're seeing some success to this already?
Sure, and it's very new also. So we're just announcing the preview today. But I think one of the things that we've seen is that on-premises is a great example of this. I've already got my data center, I've already got software in there, I've already got hardware, it's already in, ready to go. Being able to then come in and say, but I'm also using Azure. How can I just seamlessly be able to use those two? Those are kind of your common scenarios.
I see.
And again, I can now do that kind of thing where I'm doing maybe dev tests in the cloud. I wanted to deploy on premises. There's a lot of people that do that for regulatory reasons, for example.
Of course.
But now getting a very consistent set of work, but then also being able to leverage the existing infrastructure I've already got in place, that's really powerful.
And the thing I like about that is, I go out, I'm like, you should use Azure, and everyone's like, but I have this thing.
Yes.
And this is a recognition that everyone has things, and moving to Azure isn't a question of, all right, burn that down and come over here.
Correct. And that's really been part of the theme that we've mentioned since day one. I mean, hybrid was something that we put in literally, at the start of Azure. And honestly, I think that comes from having decades worth of experience actually building on-premises software, Windows Server,
right.
SQL Server, systems. I mean, all of these systems we've been building, we know what it's like to have that kind of a state and where you need to go. And so it's always been a first-class thing for us.
And that's cool. Again, get your question in, aka.ms/MS Ignite Live. The next thing I wanted to talk about was Azure Synapse.
Really
we
cool.
saw like a really cool demo. Why don't you describe what people saw?
Awesome name, too.
Yeah, I know.
Right? It wasn't like Microsoft Warehouse
for
foods,
version
a bar,
2,
visual, blah, blah, blah.
SB7.
Usually it's like a macro expansion of some kind of labeling. So
we got really cool.
It's like a nice name, which is really cool. So yeah, so the Synapse Analytics is great. And again, from an architecture perspective, I think one of the key observations is rather than having all of this data siloed everywhere, we really see this kind of convergence together of what's been data warehousing and what's been big data. Mm-hmm. And so if you think about that, rather than having to wrangle everything, move everything around and have all these silos, if we can get everything into one location and you can leverage the core files in the first place and then bring the engines to that, add serverless, et cetera, on top of that, now I start getting really powerful. So that's one kind of core piece of this. The other thing I think is really cool is being able to leverage your existing skill sets. And so, for example, we have a ton of people that are SQL experts, right? You might have spent 10, 20 years really honing those skills. Mm-hmm. You are an amazing SQL user, and you know the syntax, you know the systems. Being able to come in and say, gosh, I can now actually start to leverage AI, I can do experimentation, which is what John showed during the demo, and I don't have to actually go off and spend the next 3 years becoming a data scientist. I can actually leverage assets that might be from another part of my team,
right.
But I can still maintain those skills. I think those combinations are awesome, and it means so many more people are going to be able to take advantage of all that power.
Now, I was watching Rohan do that demo during Satya. Is this the same thing? The stuff Rohan was doing in Synapse?
It's the core. So like at Satya's demo, we introduced the first brand and kind of did the top level piece. Right. If you go back and watch, if you haven't seen it, definitely recommend watching John McIntyre's demo. He takes it one step down, shows all the importing of the data, going off and being able to create and open a Parquet file, for example.
Oh, that's
going
cool.
off and using SQL Server to actually run the query, and then finishes up by actually leveraging some data science models directly from SQL. So just with the SQL skill set there, not opening up Jupyter notebooks, not creating that might be something that perhaps as an individual, that's not something I've done before, but I can still come in with my SQL skills and figure out how to go leverage all that tech, and the engines make the whole thing just light up.
So how is this different than the data lake stuff that we had? Is it improved data lake? Is it better data lake? What's going on here?
You can think of the data lake as being the core at the base. It's the thing that stores exabytes of storage and it enables petabyte level queries, but that's its job, is the data lake has that core. So then you build up on top of that, now I can start using the runtime. So that'll include SQL Server, but also Apache Spark. So if you're a Spark user, now I can actually start running the jobs and things on top, and then the Synapse Studio is the piece that John showed off. That's the interactive piece that allows me to author the queries, run it, see the results, and get it in there. So it's a classic kind of architecture. I've got storage, I've got runtimes, and I've got basically tooling.
And so the cool thing is if you're already leveraging things like data lake, data warehouse, then you can start to leverage Synapse to do a bunch of amazing things.
Absolutely, absolutely. Because now, again, I just load a bunch of Parquet files or whatever file format that you've got. And that's the other cool thing, is I don't have to do a lot of extra data wrangling on top of that, whereas in the past, you're kind of like moving stuff around to try and get it to work. And it's simply amazing. And I will say, hats off to the SQL Server team. I mean, this is a product that we started building, almost 30 years ago.
Right.
It is constantly improved with the relational side. But if you look at the work that's been done, we've made the engine cloud native over the last 4 years. taking advantage of memory hierarchies that include blob storage and other things as well.
Right.
So it's at a cloud scale. So I get all the benefits that I've had with 30 years of relational development, all the indexing, all the smarts that go into a system like that do take 30 years to build.
Yeah, of course.
But then I get this scale out piece where I can look at all these files and all the query. I mean, like, oh my God, it's a serious piece of engineering. I'm really proud of the team. That's amazing foresight, and it's literally years worth of work to get us to this point.
And that is amazing, because I don't think people realize, like, to do a visualization on that scale of data, there's just not that many pixels on a screen to even do it, so there's aggregation happening underneath, there's fast stuff, joins happening.
Yeah.
It's pretty impressive just when I looked at it.
Well, and this is the other thing that you would have seen with Rohan. I mean, like the fact that, again, combining 30 years worth of advanced indexing, query processing skills, et cetera, making it cloud relative, like we've got the only code out there that actually takes the best of both. And that's why when you see those like TPC-H benchmarks and the rest of it, that we can make it through all of them, like the demo that John did in my keynote, he finished a petabyte level query, no cheating, petabyte level query in about 12 seconds. Like wow.
That's not normal.
Yeah, well, I mean, like you need tech to go do that. You don't just like download that someplace, right? I mean, like that, and again, that's based on 3 decades worth of really data innovation from the team.
And I mean, look, to me that's impressive, because people, like, when I used to do work for smaller companies, their database was like 4 gigs, right? That's
Sure.
that's like RAM. Yeah. When we're talking about petabytes, we're talking about this does not fit on several hard drives.
That's correct. You have to have this cloud native architecture and storage to go do it, right? And so you got to have that benefit. And of course, the thing is, the data continues to explode. So if I think about devices that are coming in, just all the data exhaust that people have, et cetera, there's so many sources of data, right? And so you can still obviously run your transactional workloads, and if you're just running a terabyte, awesome, we're gonna nail that. It's gonna work amazingly. But if you want to do insights across a lot of heterogeneous types of data and logs and all that sort of stuff, sometimes you're going to get into those very large scales. And even if you're not doing a petabyte level query next week, knowing that you've got a system that can handle that, and in fact, we do up to exabyte level storage and stuff. You think of Office and Bing and Xbox, et cetera. I mean, like we literally use exabytes of core storage to go run the business.
There might be some people out there watching this and saying, well, I'm never going to have petabyte data. But maybe they would, and let's talk about IoT and how that enables that scenario.
Yes, no, exactly. And because here we start thinking about things like time series data that comes off of devices. And of course, a lot of work that you do is incorporating other types of data. So if you look at what we've done by including weather and weather data, et cetera, I mean, imagine I got time series data off of manufacturing in a factory someplace in Germany, where I also need to know historically when the weather gets cold.
Right.
Does it actually change the way in which I do machining? Like it can actually. Mm-hmm. And so being able to search through over those sorts of data, I think is actually super interesting. So the amount of data you're going to have going forward and the access that you're going to have is going to be amazing. And it's not just going to be, your Northwind app, right?
Yeah.
Everything continues to grow.
And that's cool, because like I said, there's many people that say, I don't have that scale of data, but you might.
You might.
You might with IoT, and you might be able to enable some crazy cool experiences for your customers with that kind of data.
Yeah. Well, then think of other things too, like clickstream data that comes in. So if you're operating any kind of a public site with lots of users, there's tons of data coming through that. And again, what I would say is, even if you're not up to those scale, it kind of doesn't matter. It's not like the technology stops working if I'm not at that scale. Right. In fact, as you point out, it works even better because there's a smaller amount of data. So the point is, we've got your future protected. By the time you get off to those sorts of scales, know your system already works. And then for day, it just means that today is going to work even better.
So SQL Server 2019, generally available. Tell us about that.
Yes, fantastic. Really excited about 2019. Incredibly popular. Obviously, we've been doing a significant amount of additional work to it. This is, again, another case where this engine, and as an engineer, I super appreciate this, right? Yeah. I mean, the amount of work that's gone in under the covers, the inside of the black box, is just astounding. But its ability to scale up to all this data, it frankly has become a modern version of running analytics. I mean, I can leverage AI inside of it. Yeah. I can handle structured and unstructured data. Like this example that John showed of being able to go in and actually leverage predictive models. It's an example of pulling that AI into that. So it's not your 1990s SQL. I mean, this is modern really fantastic and cool. And of course, bringing it as well into being able to run it everywhere, at the edge, on top of Arc, and all these other
in
sort
a
of
container,
solutions.
which
in a
is
container.
really cool.
Yeah, everybody's head exploded when we added Linux in 2017. It's like, boom, now we're off into containers, and I can ship the thing off into IoT devices. It's like, wow. It's never been a funner time to be a SQL dev, I could tell you that.
All right, so a question coming in. The technical keynote briefly mentioned Cosmos DB Autopilot. If I understand correctly, this auto scales throughput based on request. Is that true, and how often do scaling events trigger?
Yeah, I mean, you got the right algorithm there. I mean, essentially, one of the big pieces of feedback that we heard was today, I want tools that are going to help me tune my throughput, how much resource that I'm using. Of course, sometimes with some of these systems, you can have peak loads. I can go peak up, I can go back down. Think of like a diurnal pattern for a website or month-end close, scale close, et cetera. Black Friday is coming up. All the retailers are gearing up for Black Friday, and they're going to have a massive amount of spiking. And so being able to go into the system, and you can tune this sort of stuff, but the autopilot piece is designed to say, how about we take some of that toil on as part of the service itself?
Right.
And so we're going to continue to have the configurations, and of course you can keep running it the way you were, but that was a big piece of feedback, is I sure wish this thing would run more automatically, and that's what Autopilot is trying to do.
So basically, it'll just scale up when you need it, scale down when you don't.
Yes, that's correct, yeah, without some of the other, I mean, essentially, and I will tell you, this is another great thing, which is the feature set that shows up in Autopilot is directly based on user feedback.
That's cool.
That's why I love this event, because we get to, there's no disintermediation with customers. Like we get to meet everybody on the floor, and they get to tell us, what would you like? What features would help?
That's cool. All right, so just to finish up, because we're running out of time, Azure Quantum, tell us about that.
Oh, Quantum's really cool.
It is cool.
I mean, anything that basically requires 20 millikelvin and like outer space is 3 Kelvin.
Yeah.
So you essentially have to create an environment that's colder than outer space for it to freaking work.
Right.
Now, a lot of the conversation that Satya covered today was thinking through what the quantum impact can be.
I see.
Just thinking about algorithms and the way that they come together, even without needing to actually have hundreds and thousands of qubits, which we don't have yet on the planet. Right. But we're all we're going to work there.
We're working on it, yeah.
But I thought that the medical imaging work and the stuff in the case study is just fantastic, because it allows you to think about these problems in a new way. I can get additional solutions, even that I can run today on scale with the cloud, and then being able to leverage the language ecosystem, Q#, the simulators, and all the rest of the software means that I can start developing those skill sets for my most advanced problem. And then as the physical world catches up and starts getting into scalable qubits and the next generation comes through, you can walk right into it, and all the skills you've built, all the investments you made are going to pay off.
And this is cool because, like for example, when we went from imperative to functional programming, just the nature of thinking about the programming problem different enabled us to consider new ways of writing code.
No, it's spot on.
Moving from functional now to quantum is going to enable those same kind of things as well.
No, that's right. Yeah, and go crack your linear algebra and calculus books again.
That's
like,
right.
My God, I cracked mine off from college and pulled those back up, and it's like, oh my God, got so much stuff to learn. But
well, I love
anyway,
that
it's
stuff.
Awesome.
Yeah, like to me, like the thing that I'm most excited about quantum is that it will open new ways to think about problems, because the way you program them is just different.
Yeah.
You're basically just shooting complex matrices at them, which are rotations around a 4-dimensional plane.
Exactly, with superposition.
That's what you told me just before we came on. That's what you told me.
Well, you know what? I have actually particle physicists on the Azure engineering team. Like, how cool is that?
That is crazy.
There's particle physicists on the Azure engineering team. Wow, that's awesome.
I feel like we need to have a moment of silence for particle physicists on the Azure engineering team. I've met some of them.
They're pretty amazing.
They're pretty amazing, and it's cool because you have people that are thinking about complex quantum problems and distilling them into an actual language. And I've downloaded it and played with it, and it's quite like, you look at a demo and you're like, oh, what is it doing? But when you realize what's actually happening, it's pretty impressive. And you can scale up to, I don't know if it was 20 or 30 qubits in the cloud, where you can test these things out in a limited way.
And start working on your algorithms and the skills and stuff. It's going to be absolutely fantastic.
Mm-hmm. Okay, so can you give us a summary of what's gone on today and what people should look to? Where can they find out more?
So definitely go check out Azure Arc. We talked about that one up front. I think that one's going to be super interesting. Lots of sessions on that. The Synapse work that we've got, I think, is just awesome, amazing. Bunch of cool stuff in there. And then I would also point out some of the Edge. And we talked a little bit about some of the Edge devices, but go check out the Expo Hall, look at the new IoT devices, Azure Edge, and that ability to run compute and AI on the edge.
Thank you so much. Well, Thank you so much for being with us. It's been a pleasure. Thanks so much for watching. And now it's community reporter time. Jeffrey Polemor is standing by to give us a tour of the Developer Architecture Center. Take it away, Jeffrey.